Hi everyone, so in this video we're going to be having a look at a few different techniques. It's not so much a video where we're going to be replicating the lab itself, but rather we're going to be having a look at how to do the procedure. In this one, it's part of the phase separation lab. We're going to be separating out this solution that has either solid barium sulfate or solid ferric hydroxide. And we're going to be using a filtration system here. So this filtration apparatus has a Buchner funnel, which you can see here. I'm going to pop a filter into it. We're going to collect our filtrate, that's the liquid stuff, in a large vacuum filtration, kind of looks like an Erlenmeyer flask with a vacuum hose attached to it. This vacuum hose then connects to something called a solvent trap, and that just ensures that no residual liquid will ultimately get sucked up into our vacuum. Then we have another pinch clamp here that we use to control our vacuum level, or rate, I guess. All right, so the first thing, and what we're doing here is we're actually timing it. We're going to see how long it takes to completely filter 100 milliliters of the iron hydroxide and compare that to the amount of time that it takes to filter the barium sulfate. And I want to show you what this liquid looks like here. As you can see, we've got very fine particles at the bottom. It kind of looks like a cloud, really. What I'm going to do is I'm going to homogenize this. Ooh, that's pretty cool. Then I'm going to pour out 100 milliliters into a 250 milliliter beaker. I'm just going to use the divisions right on the beaker itself. Closer to the edge. So 100 milliliters. And then we're going to get our filtration apparatus set up. All right, so we'll open up our vacuum. Comes up. And we can take some millipore water, and we're going to wet our filter. It's called seating it. Seating, not seating. Get that seated properly. And when we do this comparison, ensure that the vacuum flow rate is set to the same rate between the two, so that we really observe the speed of filtration that is based on particle size, not on different vacuum rates. All right, so to do this filtration, we have our beaker here with our iron 3 hydroxide. This is kind of cool. If you place a glass rod into the spout of the beaker and you hold it there, you can use two hands if you need, but starting with one hand, then you pour it, the liquid will actually ribbon down the glass rod. Let's see if this works out. And so when you guys get to doing this procedure, of course, you'll want to have a timer set up. so that we can see the effect of particle size on filtration rate. And we've got a little bit of solid leftover, so we'll rinse that in. Again, this is all accounted for in our total time that it takes to filter. That's pretty much it. So that's how we can decant from a beaker into a Buchner funnel. This liquid down below, that's known as the filtrate. And up above, that's our precipitate. Alright, so in this experiment, we're going to separate out the solid components from this Erlenmeyer flask. What's in here is I've weighed out about 2 grams of a mixture of benzoic acid and naphthalene. Definitely smell the naphthalene. If you've never smelt it before, well, that's the smell of mothballs. So I've weighed it into this flask, and I'm going to dissolve it in 50 milliliters of ethyl ether. Ethyl ether is not normally this color, but what we've done is we've added an indicator, bromocresol green, so that we can see the we can differentiate between the organic phase and the aqueous phase. So we'll take our ethyl ether. You can see I'm doing this in the fume hood. This is the volatility of ethyl ether. I'm going to dissolve the solid into the liquid organic phase. There we go. And then we're transferring that into, this is called a separatory funnel. And we use these for liquid-liquid extractions. Alright, and then to this we're going to add 25 milliliters of sodium bicarbonate. So we can squeeze that, we'll pour it in, and we should see a really interesting color change occur. So cool. Let's see that. What we have now is the organic phase is on top and the aqueous phase is on the bottom. Now the technique for performing this extraction, we have to be careful of, be aware of the volatility of the organics. They will off-gas, and this can actually become somewhat explosive. So we'll put on a lid, keeping our fingers on the lid, we invert the separatory funnel and vent it. Give it one shake and vent. A couple more shakes and then vent. And then we shake and shake and shake and shake. And then we allow the layers to separate. see here that we've got two sections. The lower is the aqueous phase, the upper is the organic. We take off our top, or subfunnel, and we very carefully drain, lower this a bit. We're going to drain the aqueous phase into a 250 ml beaker. We have to do this carefully such that as we lower the volume, this organic phase is not added into our beaker. So I'm going to try to do that as best I can. And then we're going to repeat that. So we're going to take another 25 milliliters of sodium carbonate, bicarbonate. Then we're going to invert and vent. Ooh. Give it a shake and vent. A couple more shakes and vent. And then do the proper extraction. Vent. Allow those layers to separate out. And then we'll collect the aqueous phase again into our beaker. Left hand. All right. So that was the initial extractions. We're going to do something now called a water wash, where we're going to try, well, we're not going to try. We're going to extract any remaining bicarbonate out of that ether. We're going to use distilled water for that purpose. And in this case, we're looking at 10 milliliters. In this case, because we don't have any color change, it's a little bit more difficult to see the layers, but you should be able to see it in person. Still the same technique. Invert it, vent, give it a shake, vent. Couple more shakes. And then this bottom layer we're going to collect into a separate beaker. And we'll do that a second time. Whoops, that's the bicarbonate. Gotta use the water. So the aqueous and the organic phases separate. And we can drain away the aqueous layer. All right. Good. So now, well, I won't tell you everything where everything is, but just remember the old adage that like dissolves like. And so any organics would be now extracted into our ether, and anything aqueous would be in our aqueous phase, or possibly the washings. We're now going to collect our organics into a round bottom flask. And then we're going to evaporate off the ether, and we'll be left with solid organics. Again, without giving away too much. I'll show you that technique momentarily. And then in our aqueous phase, we're actually going to use pH to precipitate out our solid aqueous compounds. And I will show you that technique momentarily. I need to go find that acid. All right, so I've got my 6 molar hydrochloric acids in here, and I've got my initial extractions in the aqueous phase. And what we're going to do is we're going to slowly add our acid, and we'll have our product precipitate out. And you want to do this very carefully, slowly, dropwise initially. It's a cool thing to watch, actually. And stirring. Kind of turns a bit of an orange color. And you continue to add hydrochloric acid until the whole solution becomes acidic. So you're adding acid in the excess. Isn't that cool? So we're precipitating out our product that's in this foam looking like material. And it is a precipitate, it is a solid. And so we're going to use the previously explored filtration technique to collect that product. Rest for a moment. I don't see any more violent reaction. And we can certainly use pH paper to confirm that it is acidic. But visually I can see that it is not reacting. So that's done. And that is pretty much it. So we'll go ahead and filter that and collect the product. And it's up to you to figure out what that product is. So that's done. We still have our organic phase over here. So I'm going to move this over to a steam bath, show you how to purify and isolate the organic product that's in there. All right, so in this step, we are going to eliminate the organic solvent, and through a process called crystallization, we're going to purify our product, collect it, and then test its purity by melting point. We're going to melt the crystals. First thing we need to do is to get rid of that solvent. So we're using something called a steam bath. That's what this is. It's a much more elegant and gentle way to boil compared to a heating plate. Don't want too much water in your cup though. So I'm going to remove, I think, one. That should work. So we're going to start our steam. No lid. Thing will blow up on us. And we'll put our round bottom flask onto our steam bath. So the ether will warm and eventually volatilize. And what we will be left with is the purified product. Again, it's up to you to actually work it out exactly what that product is. Again, all of this is done in the fume hood because of the volatility of our of the solvent. I'm going to let that continue. It will take a few minutes. When we come back, we'll have a look at what that final product looks like. It's a little bit too hot. So again, you don't want it to be boiling. Just kind of want it to be evaporated. So I'm just turning down the steam a little bit there. It's going pretty good. Maybe it won't go away. Maybe I'll just speed up this part of the video. It's quite a visual phenomenon once you see the crystals form. If we do this in a very gentle manner, these beautiful white shards of our product will just start to appear. Again, I think I mentioned it earlier, this is a purification step. So we're getting rid of the solvent, and depending on how well we did our extraction, we shouldn't have any water in here. Water would be considered a contaminant. Not quite there yet. Let's see, around the top, the neck here, there are starting to get some white crystals forming. That's there because as I spun the liquid, it's cooler around here, and the heat can keep the crystals in suspension, whereas on the cooler side, they'll actually crystallize properly. So I'm just playing with that a little bit. Let's see, more and more crystals form, and they are colored, which means that my extraction technique is not as precise as could be. What we could do is put these crystals back into suspension with more ether, and then wash it again with water, as we did previously. That'll further purify our product. Another thing we could do is add a decolorizing agent, such as activated carbon or activated charcoal, and that would remove some of that color as well. All right, I'll let that continue to evaporate for a little bit, and I'll set up a melting point apparatus, and then we'll see what that technique looks like. All right, so I've got everything we need to do our melting point. What I've done is I took that round bottom flask and I scraped the insides and collected all of our purified crystals and put it into this watch glass. Depending on the condition of your crystals, you might be interested in actually getting a mortar and pestle and grinding it. We want the crystals as fine as possible in order to do this melting point. We then take a capillary tube designed for melting points. That's what this is here. And we're going to tap the open end into our crystals. Might need to scoop a little bit. These crystals have been sitting around, actually it's been a couple hours, so they're really, really dry. Yours may be a little bit stickier and wetter, so it will work well to tap. And you'll find that many of the crystals will get stuck on the inside of the tube. And so what we need to do is try to get them all the way down to the bottom. And that's where this guy comes in. So using gravity, we will put our tube, our capillary tube, into the top of this glass and just let it drop. And we'll do that a few times. And that will pack all of our crystals down to the bottom. So let's see here. We have a very, very small amount, probably about 2 millimeters worth of our crystals. Then we're going to use this Meltemp melting point apparatus to actually melt our crystals. If you look down the top, there's a slot with 3 little holes in it, and our capillary tube will fit into one of those slots. That. And then we control the temperature using the dial here, and we monitor the temperature using the thermometer. And then inside this little window is it's almost like a magnifying glass that focuses it in the bottom of the capillary tube, so you'll be able to see your crystals melt. Melting point is not only one temperature, it is actually recorded as a range. So the temperature that you see the very first crystal turn into a liquid is the start of the melting point range, and then when all of the crystals have melted is the end of the melting point range. Your purity is dictated by how narrow that range is. So if you can get all of your crystals to melt within 2 or 3 degrees, that's really good. If you have quite a broader range for your melting point, that is indicative that there are impurities in your product.